Hi folks, welcome back to 6.3 practice. Now in this video we're going to take a look at question number 2 and we're going to approach it using washer method. To see the same question solved using shell method, please see video number 4. Alright, so question number 2 says find the volume of the solid of revolution generated by rotating the area between the graph of f of y equals 2 times the square root of y and the y-axis over the interval y is between 0 and 4 around the x-axis. Okay, so let's start by drawing our diagram. So I'm going to have f of y equals 2 times the square root of y in orange, and I'm going to have the y-axis in blue, and we're going to have our axis of revolution in the yellow. Okay, so let's go ahead and draw that. So I've got my axis of revolution. I know it's going to be the x-axis. I know that my graph of the y-axis is going to be in the light blue, so I can draw that right here. Okay, and then I have this graph f of y equals 2 times the square root of y. Now I might not know what that looks like, but don't forget that you can always look and use a table to help you figure that out. So plug in a few nice points, see what you get. So when I plug in 0 for y, I'm going to get 0 for x, which means that 0, 0 is a point on my curve. When I plug in 1 for y, I'll get 2 for x, so I know the point 2, 1 is on the curve. And finally, when I plug in 4 for y, I'm going to get 4 for x, and so that's going to be the last point that we use to help us sketch. So if we connect these 3 points, we'll end up with something kind of like this, all right? Now, it seems like there's no top to this. However, knowing that y is only going from 0 to 4, I can go ahead and seal off that region, okay? So I'm going to seal that off at 4. And so now I have a region very clearly bounded by the blue, the orange, and the pink. Now, because I'm rotating about the x-axis, I'm going to go ahead and sketch the reflection underneath. Okay. Now, if we're using washer method, what we're saying is our slices are circles or washers, and they are going to be perpendicular to the axis of revolution. That means that I don't want to draw something like this because that blue line is parallel to the yellow line. So I'm going to undo that, and I'm going to draw a line that is perpendicular to the x-axis. So for example, I might have one here, okay? I might have one here, and I might have one here. Now, as I'm drawing these blue lines, what I notice is that I have to think about the length of this line, and that's going to require me to do top minus bottom. Okay, so top curve minus bottom curve, or in this case, our top curve is the pink one, and our bottom curve is the orange one. All right, so let's set up our integral for washer method. So volume equals pi, the integral from a to b of big R squared minus little r squared dx. Now I have my pi, my x values of the points that I'm starting and stopping at. Let's see, this point is 0, 0, and this point is 4, 4. So I'm going to pick the x values of both points, 0 and 4, and those will be my bounds. All right, so I have a top minus bottom, okay, and that's how I knew that I was going to be using washers, not disks. Now, the curve that has a greater distance from the axis of revolution is the pink one, and that line is 4. So I need 4 squared. That 4 is my big radius, and I have to square it because it's big R squared. Minus the little r is the one that is closer to the axis of revolution, and in our case, that's the orange function. So 2 square root of y squared dx. All right, now that means, again, little r is 2 square root of y, or the bottom curve. Now, when I look at this, I'm already seeing some issues because I have an x and a y. So I'm going to need to rename that curve in order to make it suitable for the equation. So let's take this. I really have x equals 2 square root of y. So I'm going to divide both sides by 2. Then I'm going to square both sides. Now, x squared minus 4 is what I should use instead of that 2 square root of y, so that all of my letters match. Okay, let's plug that in, and then we will simplify, and then we will integrate. Okay, and now I'm going to distribute that square in the little r. All right, looks like I'm ready to integrate now. So I have pi times 16x minus x to the 5th over 5 times 16 is 80. And I'm going to drop the line, put a 4, put a 0. Now I can already tell that because I have a 0 as my bottom bound, and like if I plug in 0 here, it's going to give me 0. If I plug in 0 here, it's going to give me 0. So I'm not going to write out that minus 0 part. I'm just going to plug in the 4, okay? So pi times 16 times 4 minus 4 to the 5th over 80. All right, this gives us pi times 64 over 1 minus 1024 over 80. Now this 1024 over 80 reduces to 64 over 5. So that means I need a common denominator of 5. So when I do that, I'll get 320 minus 64 over 5, or I'll get a final answer of 256 pi over 3. All right? So that is how we solve this problem using washer method. In the next video, we're going to get the same answer for this because we have the same shape, but we're going to apply the shell method instead. All right, so I'll see you back here for video number 4.